Hi friends, in this video we are going to discuss about quadratic form. So here the definition of the quadratic form is a homogeneous polynomial of second degree in n variable is called the quadratic form. Here an expression of the form summation I running from 1 to n, j running from 1 to n, aij, xi, xj, where aij equal to aji means in the coefficient matrix. For example, let's say this is your matrix A. Here the coefficient of this matrix are aij. Here let's say this is the n is square matrix of order n cross n. Here summation I run from 1 to n, j run from 1 to n, aij, that is the coefficient of this coefficient matrix, xi into xj, where aij equal to aj means here a. So for example, this is a11, a12, a21 and a22. This means here a12 is same as a21, here aij is same as aj, all are real, is called a quadratic form in n variable x1 x2 up to xn. Here now how to write this quadratic form for any matrix? So here we will discuss. So this is the quadratic form in n variable x1 x2 up to xn. So here I want to write this expression for two variable, that is here I will take, either you can take x and y as unknown variable, or you can take x1 and x2 as unknown variable, that's your choice. Here first I will write for two variable, here two variable, for two variable x1, here in x1 comma x2, here I will write in the bracket. Now I want to write this expression. This means this is same as here summation I running from 1 to n, 1 to, here number of variables are 2, summation j running from 1 to 2, a, I, j, x, I and x, j. So here do one thing, first put I equal to 1, here this is equal to, here I will write summation I equal to 1. So here for I equal to 1, summation, so for I equal to 1, summation j running from 1 to 2, a, I, j, so here and x, I and x, j, plus, so here I will write for I equal to 2, summation j running from 1 to 2, a, I, j, x, I and x, j. So here in my first part, here I am putting I equal to 1. In my second part, here I am fixing I equal to 2, and in my first j running from, j is running 1 to 2, here in the second also I is fixed to and j is running 1 to 2. So here I will write this is equal to, here this is equal to, here I is 1, so j is running from 1 to 2 means a 1, so here I is 1 and j is 1, so this is x is 1 and j is 1, so for first time. So here now here since again I is 1, so I 1, here j is now 2, so 2 x I, that is 1, and j x j, that is 2, plus, so here I want to write this term, so here this is my this term, here this part is over. Now I want to write this part here. Now in the second part, here I is fixed 2, that is a 2 and j, here I am changing j equal to 1, x 2, here I is fixed and here j is first time 1, plus I j running from 1 to 2 means second time, plus a 2, so here j is I is fixed, j I is 2, here j is now this times 2, a 2 2 and this is x2 and this is j is now 2. So this is the matrix form, this is the quadratic form in two variable. But here a I j in the definition of the quadratic form they said a I j is same as a j I. Now you can observe these things here. This is a11, here this is a12, this is a21 and this is a22. But here a12 is same as a21, so here I will write as it is a11, this is x1, this is x1, can I write this is x1 square, plus a12 is same as a21, so if a12 is same as a21, can I write 2 times a12, here x1 x2, plus now this is a22, so here x2 square. So here this is the quadratic form in two variable x1 comma x2. So here we can write this expression for two variables, that is two unknown x1 x2. So this is the one way. But here another way to write here. So this is the matrix. So here I will write. So in the same form, let's say A first row. So for example, if you have 2 cross 2 matrix, here I am writing general matrix A11 here, and the first row of your matrix is A11 and A22, and the second row of your matrix is A21 and A22. So here do one thing. This is the 1 comma 1 position here, and this is the here. So here, for example, if you have 2 cross 2 matrix, first row is A11 and second that is this is A12 position. Here this is second row A21 position. This is A22 position. Now here corresponding to A11 position, you can observe one thing. This one is corresponding to the first unknown x1, and right this is corresponding to this position, this one, that is j is 1. So write the again x1 position. Now come to here, this is corresponding to this one, right here x1, corresponding to this 2, right here x2. Now come here, corresponding to this 2, right here x2, and corresponding to this position, right here x1. In the same way, corresponding to this 2, right x2, and corresponding to this 2, right x2. So here in this way you can write. So here can I write here, this is same as here A11 into x1 and x1 plus A12 x1 and x2 plus here this is A21 x2 and x1 plus A22 x2 and x2. So here this is same as A11 here x1 square plus, so here A12 is same as A21. Can I write here 2 times A12 x1 x2 plus 2 times here, this is A22 and x2 square. So here in this way also you can write. So here first write any matrix. So here first write any matrix. So let's say here this is the matrix A11, A12, A21, A22. So here this is the first row. Here A11 means 1 is the, here this one is corresponding to the first unknown x1. This one is corresponding to the unknown x1. Here this is 1 1. That's why I write x11. Here A12, right, x1 x2. Here this is x21, right, x2 x1. This is A22, right, x2 x2. So here A11 x1. So here A11 x1 plus A12 x1 x2 plus A21 x2 x1 plus A22 x2 x2. So write this, you will get the same form. So here this is the one way, but this is the another way. For example, I want to write the quadratic form in for 3 cross 3 matrix. So for example, let's say here I will write here. So for example, this is the 3 cross 3 matrix. In 3 cross 3 matrix, first row is A11. Here first row is A11, A12 and A13. So here corresponding to A11, here I am writing x1 1. Corresponding to A12, here this 1 2 means this 1 is corresponding to the first unknown. This 2 is corresponding to the second unknown x2. This 3 is corresponding to the third unknown x3. So here corresponding to A11 means here this corresponding to 1 and this position 1 position corresponding to again x1. So here this is 1 2 position. Here I am writing x1 and x2. So this is 1 3 position. Here I am writing x1 and x3 position. Now come to the second row of this matrix, third 3 cross 3 matrix, A21, A22 and A23. So here this is x2, here x2 x1. Now this is x2 and x2. Now this is x2 and x3. Now here this is x3. Now third row is here A31, A32 and A33. So here A31 means x3 and x1. Here this is x3 and x2. So here this is x3 and this is x3. Now, so for example, this is the 3 cross 3 matrix. First row A11, A12, A13. So here A11 means this is 1, this is 1. Here I am writing x1, x1. This is 1, 2. Here I am writing x1, x2. This is 1, 3, A13. This is 1 and this is 3. Here I am writing x1, x3. So here this is A21. Here I am writing x2, x1. This is A22. Here I am writing x2, x2. Here this is A23. Here I am writing x2, x3. This is A31, x3, x1. A32, x3, x2. A33, x3, x3. So here the quadratic form in 3 variable. That is here expression, that is I running from 1 to 3, j running from 1 to 3, a I j x I x j, which is equal to here write a11 x1 x1 plus a12, so corresponding to first row x1 x2. So this is a13 position, x1 and x3. Now come to the second row. Here this is equal to, here I am writing this is corresponding to the first row. Here second row entry of the matrix is a21. So this is 21, right? x2 x1 plus here a22, right? x2 x2 plus this is a23, right? x2 and x3. So now corresponding to the third row of the matrix is a31, a32, a33. So this is that is a31 x3 x1 plus here a32, so x3 x2. Here this is a33 position, right? x3 and this is x3. So here since in the quadratic form aij is same as aji, that is here I will write this is a11 as it is and x1 into x1 square plus this is a12 is same as a21. So here this is same as this, so that's why here I am writing 2 times a12 x1 and x2 plus, now come to here this is a13. So this a13 is same as a31. So here this a13 is same as this a31. So here from here I am writing so a13 2 times a13 x1 x3 plus, now here this is covered with this. Now come to here, now plus a22 x2 square. So here I am writing this term. So where is that? a22 x2 square. Now come to a23. Now a23 is same as a32. Here this is a23 and this is a32. Can I write 2 times here? 2 times plus a23 x2 and x3. So here up to this cover. So this is covered with this. Now come to here a31. So here a31 is covered with this a13. Now here up to this cover. Now here last is a33 plus a33 x3 square. So here this is the quadratic form in 3 and 1, x1 x2 x3. Here the trick is that, so whenever you have 3 cross 3 matrix, right, first column that is right, first row a11 a12 a13, second row a21 a22 a23, third row a31 a32 a33. So here this is the a11 position. So this 1 comma 1 position is corresponding to the, here this position corresponding to x1, 1 is corresponding to x1, this 1 is corresponding to x1. Here 1 2, this 1 is corresponding to x1, 2 is corresponding to x2. Here 1 3, here 1 is corresponding to x1 and 3 is corresponding to x1. That is here I will write here, for example 1 2 3. So this 1 is corresponding to first unknown x1, this 2 is corresponding to second unknown and this 3 is corresponding to 3 unknown. Here whenever you have a11 position, so here a1, here 1 1 means 1 comma 1 x1 x1. Here 1 2 means 1 comma 2. For example here I am writing 1 1 position. So here I will write this is 1 1 position. 1 is corresponding to x1, this 1 is corresponding to x1. Here 1 2 position, this 1 is corresponding to x1, this 2 is corresponding to x2. Here x1 x2. This 1 is corresponding to x1, this 3 is corresponding to x2. That's why x1 x3. In this way you can write for any unknown. So this is for this is the quadratic form in 3 variable x1 x2 up to x3. So in this way now I want to write quadratic form for let's say 4 variable. Let's say x1 x2 x3 up to x4. So here I will write here. So this is for 2. So I think I already explained. So here this is for 2 means here 2 case. This is instead of this here in this way also you can put first I equal to 1. So change j. Second times fix I equal to 2. Change in j. So here in this expression how we, so instead of this is the one technique, but here, so here how to write, so by using this. So here both are correct. So here I will write. So here I want to, so this is the other way. So here I want to write this quadratic form in 3 variable form by using this. Here this is I equal to, here 1 to 3, j equal to 1 to 3, a I j x I and x j, which is equal to here. So fix I equal to 1 first time. So here fix I equal to 1 and change in j equal to 1 to 3, a I j x I and x j, plus second times fix I equal to 2. So here I am fixing I equal to 2. So this is my I equal to 2, and so j is changing, j equal to 1 to 3, a I j x I and x j. So third time, so fix I equal to 3, so change in j equal to 1 to 3. So a I j, so a I j, this is x I, this is x j. So here you can solve this, which is equal to, so here which is equal to, here I is fixed. Can I write here? Here. So here I is fixed. So here this is a1. Here I is my 1. Here a1. This is, sorry, a1. J is 1. Here x1 and this is x1, plus I is fixed. A1. Here x1 and x2, plus again I is fixed. So here this is a1. So now this time j is 2. Now here a1, so j is this times 3. So here x1 and again x3. So this is corresponding to this for when I is 1. So here a1 1, x1 x1, plus a1 2, x1 x2, plus a1 3, x1 x3. So this is my first. So corresponding to this first. Now fixed I equal to 2. Here fix I equal to 2, a2 1. So here x2 x1. So here now this time j is 1. Here j I is 2, now this time j is 2. So here x2 and x2, plus now this is a2 and this is x is, now this time x is 3. So here x2 and x3. So here this is same as this second. Now in this same way, now this time here I am fixing, so I equal to 3. So here this is a3 and j is this times 1. So here x3 and x1, plus here this is a3, that is fixed. Now j is 2. This is x3 xi and xj is here x2, j is 2, plus this is a3 and here j is also 3. So here x is 3 fixed and j is 3. So this. So you can solve this. Here a12 is same as a21. So this is a11 x1 square, a11 x1 square, plus a12 is same as a21. That's why 2 times a12 x1 x2, plus in this way. So in this way also you will get the same. So here so you can solve this way, or you can so this is the technique. So here first row a11, this 1 1 position is corresponding to x1 x1, a12 1 is corresponding to x1, 2 is corresponding to x2, a13 x1 is corresponding to x1, 3 is corresponding to x3. In this way for any. Now here I will write using the both for 4 variable. So here how to write quadratic form in 4 variable. So you will get complete idea. So here first I will write, so for 4 variable, so here, so instead of that here I will use, so here for example I want now here 4 variable means 4 cross 4 matrix. Here I am taking 4 cross 4 matrix. First row is a11, so first row is a11, second first row a1 2, a1 3, this is a1 4. So here this is a2 1, a2 2, a2 3. So this is a2 4. So here third row is a3 1, a3 2, a3 3 and a3 4. So fourth row is a4 1, a4 2, A4 3 and A4 4. Now here 4 variable means here I have 4 unknown, that is here x1, x2, x3 and x4. Here I have 4 unknown. So here this is 1 position. This 1 position is corresponding to here x1 x1. This is 1 2 x1 x2. This is 1 3 x1 x3. This is 1 4 x1 x4. Now here, so this is corresponding to this. Now this is A21. Here x2 x1, A22 x2 x2, A23 x2 and x3. This is A24 x2 and x4. So here now third row, here I am writing this is x3 x1, this is 3 2 x3 x2. So this is 3 3 x3 x3. So this is 3 4 x3 and x4. So here this is 4 1. So here I am writing. So here I am writing for x. This is x4 1, x4 x1. This is x4 x2. This is x4 x3. This is x4 and x4. Now here now I will write. So this is equal to here. So quadratic form, that is for in 4 unknown. So here a1 1 x1 and now this times I will write directly a1 1 x1 and x1 square plus a1 2. So here a1 2 is same as a2 1. Here I am writing 2 times x1 and x2 plus here a1 3. A1 3 is same as a3 1. That's why here I am writing 2 times a1 3 x1 x3. So here now so here this is a1 4. A1 4 is same as a4 1. So here this is a1 4. A1 4 is same as a4 1. So here that's why here I am writing 2 times a1 4 x1 and x4 plus now so now come to here this a21 is covered with this one. Now come to this a22. Here a22 x2 square plus this is a23. This a23 is same as a32. So here I am writing a times a23 a23 and x2 and x3 plus now this is a24. A24 is same as a42. So this is a24. This is a42 same. Here 2 times a24. This is x2 and x4 plus now here a24 up to this cover. Here now come to a33. Here plus a33 x3 square plus now come to a34. A34 is same as a43. That is a34 is same as a43. Here 2 times a34 x3 and x4. Now last is here plus a44 x4 square. So here this is the quadratic form in 4 variable, that is x1 a1 1 x1 square plus 2 times a1 2 x1 x2 plus 2 times a1 3 x1 x3 plus 2 times a1 4 x1 x3. So you can write up to a4 4 x4 square. So this is the quadratic form in 4 variable x1 x2 x3 x4. So here you will get this same equation by using this formula also. Here this is just here matrix static means first row a1 1 a1 2 a1 3 a1 4 x1 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 x2 this x1 x3 x1 x4. Second row a21 a22 a23 a24. That is my second row of the coefficient matrix. Here x2 x1 x2 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 x3 and x2 x4. Here third row a31 a33 a31 a32 a33 and a34. Here x3 x1 x3 x2 x3 x3 and x3 x4. Now fourth row, that is a41 a42 a43 a44. So here x4 x1 x4 x2 x4 x3 x4 x4. So here you can in the same way also this by using this also you will get same thing. So here I will write, so by my here both are same. So this is equal to the quadratic form in here 4 variable, that is I running from 1 to 4, j running from here 1 to 4. Sorry, this is 1 to 4. So that is a I j x I and x j. So here first time fix I equal to 1. So first fix I equal to 1. Here I will directly write here so fix I equal to 1. Here that is I equal to 1. So directly writing here I equal to 1 and this is j. Here I is 1. Here I am fixing I and this is x j. So here second times. So here I am writing. So sorry. So I want to write one more summation here. Here I am fixing I equal to 1 and change j equal to 1 to 4. So this is a. Here I is my 1 and j is changing, and this is I is my 1 and j is changing. Plus now this times fix here, fix I equal to 2. Here I am fixing here I equal to 2. Here summation j running from 1 to 4. Here I am fixing I equal to 2. Here 2 j. Here this is x2 and xj. So now plus this times I am fixing j equal to I equal to 3. That is I equal to here I equal to 3. Here change in j running from 1 to 4. I is my 3. This is j and here x3 and this is xj. Now plus fix I equal to here 4 and change in j equal to 1 to 4. You will get here a I is 4 fixed and j is changing, and here I is 4 and j is changing. So now you will solve this equation. You will get this. Here first I will write for. So here corresponding to this, here corresponding to this, you will get a11 x1. Here I will write here corresponding to this. First I will write a11 x1 x2. So here I will write for. Here j is writing from 1 to 4. Here I will write 4 term. a11 I is my fix, x is. So here j is 1. So here a12 x1 x2 plus I is 1 a13 x1 x3 plus a14 x1 and x4. J is 4. Now corresponding to, so this is corresponding to this. Here I got. Now j I is equal to this. I equal to 2. Here I am writing for I equal to 2. Here I am writing this here. Here a2 j is 1. Here x2 and j1 plus a22 x2 and x2 plus a2 3. So j is 3. So here x2 x3 plus a24 x2 here and x4. Now plus. So here I will write for fix I equal to 3. Here I will write here a31 x3. This is j is 1 plus a32. That is j is 2. Here x3 and x2 plus a33 x3 3. Sorry x3 and x3 plus a34 x3 and this is x4. Now so corresponding to this I, when I is 4. Here a41 x4 and this is x1 plus a42 x4. This is x2 plus a43 x4 and x3 plus a44 x4 and this is here again x4. So here since a12 is same as a21, so here this is 2 times. a13 is same as a31. This is 2 times a13. a14 is here. a14 is same as a41. So this is 2 times. You will get this same expression. So in this way you can write any quadratic form for 2 variable, 3 variable, 4 variable. So either use by matrix. In the matrix form. So for example here again I will once here. So I think no need to repeat here. So for example if you have 2 cross 2 matrix a11 a12 a21 a22. So here I am. This one position. This 1 is corresponding to first unknown. 1 is corresponding to second unknown. 2 is corresponding to second unknown. 3 is corresponding to here. So if we have 2 cross 2 matrix. Here we have x1 and x2. So here this one. So you can write here x1 and x2. Here so 1 means here x1 x1. 1 2 here x1 x2. Here 2 1 means x2 x1. Here 2 2 x2 x2. So here in this way you can answer. Here means if you have 2 cross 2 matrix a11 a12 a21. So 1 1 position is x1 x1. 1 2 position is x1 x2, 2 1 position is x2 x1, and 2 2 position is x2 x2. So in this way you can write. Now how to write? This is the quadratic form in 2 variable, 3 variable and 4 variable. But with the help of quadratic form, how to write the matrix notation of the quadratic form? So how to write? So by using this, how to write the matrix notation of the quadratic form? That is here. So first I will write for 2. So after that again I will write for 3 4. So here you will get your more practice. So here again I will write for quadratic form in 2 variable. Let's say this is q equal to, here q equal to I running from 1 to 2 and j running from 1 to 2. This is a I j x I and x j, which is equal to, here just now I have written. So this is corresponding to, here I am writing a11, a12, a21, a22. So here this is corresponding, that is a11, here 11, here x1 square, x1 x1 plus a12 is same as a21. That's why here I am writing a12, 2 times a12, x1 x2 square plus this is a22, here a22 x2 square. Now here, so this is the quadratic form in 2 variable. Now so you can solve here. This is quadratic form, here x is here x1 x2. So this is the column vector up to unknown x1 x2, and here I want to write, here this is x1 x2. Therefore q equal to, you can solve this x transpose ax, you will get this same expression. Here q equal to, you can solve this expression. Here if you just solve this expression, so you will get the same thing. Here I will write here. So for example, so I will solve this. You can solve x transpose ax, you will get the same. This is the quadratic form. Here x transpose is here x1, this is x2. Here a is 2 cross 2 matrix. Here a11, a12, this is a21 and this is a22. And here this is my x1 and x2. So here just you can solve this. Here first row first column. Here a11, x1, first row first column plus here plus a21 x2. Here first row first column is this position. Here first row second column is this position. Here a12 x1 plus a22 x2. So here and here this is x1 and x2. So here now, so first row first columns. Here first row first column means here this is x1 into a11 x1 plus a21 x2 plus this is x2 into a2, that is a12 x1 plus a22 and this is x2. So this is equal to, here a11 x1 plus a12 a2, here x1 x2 plus a12, here a12 is a21 is same as a12, that's why I am writing x1 and x2 plus a22, this is x2 square. So which is equal to a11 x1 square plus 2 times a12 x1 x2 plus a22 x2 square. Here so you will get the same expression. So here how to write? By using this I want to find this matrix A. So for quadratic form, how to find this matrix? Here matrix notation of the quadratic form, how to find? Here so this is the quadratic form in 2 unknown. Here I want to find the matrix notation of the quadratic form. That is, I want to, with the help of this quadratic form, I want to write the matrix notation of the quadratic form. That is q equal to x transpose ax. Here this is the quadratic form in 2 unknown. That is x1 x2 means there are 2 unknown. That is, one is x1 unknown, second unknown is x2. So here all of you know x is, this is the column vector, simple, x1 and x2. Here and x transpose is just first row becomes first column, second row becomes second column. Here this is the matrix of order 1 row, here 2 row and 1 column, and x transpose is here x1 and x2. So you will get 1 row and 2 column. Now how to find this matrix A with the help of this quadratic equation. So matrix notation of the quadratic form is the following. Now since right there this is equal to right x transpose. So here x transpose, that is here I will write. So here number of unknowns are 2. So here x is the column vector and x transpose is the row vector. That is here x1 and x2. Now here I want to write a is the here, and here this is again x1 and x2. Now here this is the a11 position. Here coefficient of x1 square is a11 position. That is coefficient of x1 square is this, and second position is a12. Here coefficient of x1 x2. Sorry, this is a coefficient of x1 x2. But here coefficient of x1 x2 is same as coefficient of x2 x1. So here this is means coefficient of x1 x2 is same as coefficient of x2 x1. So you can take divided by 2 times this. Here I will write here coefficient of x1 x2, so divided by 2. So just write coefficient of x1 x2 divided by 2. So this is 2 times. Here 2 gets cancelled. You will get there here a1 2. Here this is same as here this is a12 position. This is same as a21 position. So this position is same as this position. So write here coefficient of x1 or x2 divided by 2. So here write coefficient of x2 square. This is coefficient of x2 square. Here write here this is equal to x1 x2. Now here coefficient of x1 square is a11. Here coefficient of x1 x2, coefficient of x1 x2 is 2 times a1 a2. So here if I write here 2 times a1 a2 divided by 2 here, and this is 2 times a1 2 divided by 2, and this is coefficient of x2 square is this is a2 2, and here this is x1 and this is x2. So here this 2 gets cancelled. This is equal to here x1 x2 here this is equal to here this is a11. This is here 2 gets cancelled, a12 here again a1 2, and here this position is same as this, and this is a2 2, and here this is x1 and x2. So here in this way this is the matrix notation of the quadratic form. This now in the same way I want to write the matrix notation for quadratic form for 3 unknown. Here this is for 2. Here I will write for 4. So here, so I think all of you know how to write the quadratic form in 3 variable. So here how to write matrix notation corresponding to this quadratic form. Here summation. So summation I running from 1 to 3, j running from here 1 to 3, a I j x I x j, which is equal to here I will write first columns a11 x1 square directly. This is a12. So here this is a12 x1 x2. So here a12 is same as, so here first I will write a12. Here this is a13 x x1 and x3. So here plus a14 here a14 x1 x4 here. So here directly write, so no need to again here. This is 2 times a1 2 x1 x2 plus, now this is a12 a2 2, sorry a13 position, a13 is same as a31. So here 2 times a13 x1 x3. So here a13 a14. Now a14 is same as a41. Here write 2 times a14 x1 x4. Now here first corresponding to first row. Now here I will write just format is here a11 a12 a13 a14. Here a21 sorry a13, sorry here we are writing for 3. Here a13, so a13, so this is not here. Now a13 a21 a22 a23 a31 a32 a33. So here a11 x1 square. Here a13 is same as a21 2 times a11 x1 x2 plus a13 is same as a31 2 times a13 x1 x3. Now come to here this position plus a22, so x2 square plus, now come to this a23 is same as a32. Here 2 times a23 x2 and x3 plus, Now come to this position. Here a 3 3 x 3 square. Now I want to write the matrix notation. So here matrix notation corresponding to this quadratic form. So here this is therefore here matrix notation. Therefore matrix notation of quadratic form in three variable is here q equal to here x transpose a and x. Here a is coefficient matrix and x is the column vector x1 x2 x3 like this x1 x2 and x transpose is the row vector x1 x2 x3. So here I will write here I get the same matrix here a11 a12 a13. So here this a12 is same as a21. So here just write a12. Here this is a22, this is a23, and here this is a23, and here this a1 now a11 a12. Here a12 is same as this. This is a13. This a13 is same as a31. So here write a13. Now come to here. This is a22 as it is. a23 is same as a32. So write here a23. This is a33. Here I got the same matrix by this also. Here, but I want to write in terms of this. So while solving the problem, you will get more idea. Now this is same as here. So first write row vector of x1 x2 x3, that is equal to x1 x2 x3. Now here first here a11, that is coefficient of x1 square, coefficient of x1 square. This is a12, coefficient of here x1 x2 divided by 2. Now this is a13, here coefficient of x1 x3 divided by 2. Now this is a21 position. Here a12 is same as a21, so write this as it is here, coefficient of here x1 x2 divided by 2. So here coefficient of x2 square. Here write a23, coefficient of x2 and x3. Now here this is a31 position. Here a13 is same as a31, so write this position as same here. So here cross here coefficient of x1 x3 divided by 2. Here this is a32 position. A32 is same as a23 here. So sorry, this is divided by 2. Here this is coefficient of x2 and x3 divided by 2. So this is coefficient of x3 square. Here along the diagonal, along the principal diagonal, write coefficient of x1 square, coefficient of x2 square, coefficient of x3 square. Here this is a12 position. So this is same as a21 position, write as it is. So here this is a23 position. This is same as this. Here you can stop here. So here first write diagonal element x1 square, coefficient of x1 square, coefficient of x2 square, coefficient of x3 square. After that just swap this same here. This is same as this. This is same as this, and this is same as this. Here cross positions are same. Here cross position a12 is same as a21, a13 is same as a31. Here a13 position is same as a31, a23 position is same as a32, and here this is x3 square. So here in this way you can write. So here now how to write matrix notation for quadratic form in 4 variable. So I will write this. So most of the times up to 4 they will ask in exam. So here how to write for 4 variable. So here again I will write q equal to summation I running from here 1 to 4, summation j running from 1 to 4 a I j x I x j, which is equal to here I will write row wise here a11 here a11 x1 square plus a here, so here start from here. So here this is a11 here x1 square. Here this is a12. So a12 is same as a21. So 2 times x1 and x2. So here a13 is same as a31. So here 2 times, here I will write here, plus here 2 times a13 x1 x3 plus a14 a1 4 is same as a4 1. Here a1 4, here 2 times a1 4 x1 x4 plus now up to a1 4 now a2 1. So here first write the matrix. Here a1 1, a1 2, a1 3, a1 4, a2 1, a2 2, a2 3, a2 4. This is a4, sorry, a3 1, a3 2, a3 3, a3 4, a4 1, a4 2, a4 3, a4 4. Here, so this is matrix of order 4 cross 4. Here a1 1 x1 square, a1 2 is same as a2 1, 2 times a1 2 x1 x2 plus a1 3 is same as a3 1. So here this is same as this, a1 3 is same as this, right? 2 times a1 3 x1 x3 plus a1 4 is same as a4 1, 2 times a1 4 x1 x4. Now come to here directly here plus a2 2 x2 square plus now a2 3 is same as a3 2. So here I will write 2 times a2 3 x2 and x3 plus here a2 4 is same as a4 2, 2 times a2 4 x2 and x4 plus here now come to directly here. So here this is covered with this, now come here a3 3 x3 square here plus now here a3 3 is covered. Now a3 4 is same as a4 3. So directly here 2 times a3 4 x3 and x4 plus here plus a4 4 x4 square. So here in this matrix here, so you will get this matrix here. So you will get this matrix after writing in this form. So with the help of I will write this here. So sorry, this is here x1 x2 here, x1 x2, so x3. So in terms of 3 we forgot here x transpose is this, a is my this matrix and x is this. Now here I want to write same thing here. Now this is a1 1, this a1 2, a1 2 is same as a2 1. So here I will write this is a1 2, a1 3 is same as a3 1. So here I will write a1 3. So here a1 4 is same as a4 1. So here I will write here a1 4. Now this is a2 2, a2 3 is same as a3 2. Here a2 3, this is same as here a2 3. This is a3 3, a3 4 is same as a4 3. So here I will write, so here I will write a3 4 and this is a2 4 is same as a4 2. So here this is a2 4 and this is a4 4. You will get the same answer here. So first I will write, so how you will get the same answer. So here which is equal to, here you can write here first I will write here x transpose, here x transpose x1 x2 x3 and x4 which is equal to here. So I will extend this for so matrix in 4 cross 4 matrix. So here I will write, so first I will write the, so how to, here this is equal to, here I will write x transpose, I don't have space, which is equal to here coefficient of x1 square, here coefficient of x1 square is here a1 1, here coefficient of x1 square, this is a1 1. Now coefficient of x1 x2, here I got, first I will write here coefficient of, here coefficient of x1 square. Now coefficient of here x1 x2 divided by 2. Here now coefficient of, here coefficient of x1 x3 divided by 2, coefficient of x1 x4 divided by 2. So this is my first row. Now so this is a1 1 position, a1 2 position, a1 3 position, a1 4 position. Now a1 2 is same as a2 1. Here I will write coefficient of here x1 x2 divided by t. I will write this as it is. Now this is the diagonal entries. Here coefficient of x2 square as it is. Now this is a2 3 entry. Here coefficient of x2 and x3 divided by 2.
So this is A24 entry, coefficient of x2 and x4 divided by 2. Now this is here A31. So here A13 is same as A31. Here I will write here coefficient of x1 x3 divided by 2. Here this is A13 here this is A31 A32 position. Here A32 is same as A23. Here A32 is same as A23. That's why here I am writing same here. A coefficient of here x2 x3 divided by 2. Now here coefficient of x3 square. Now here A34 here write coefficient of x3 x4. Now this is A41 position. A41 position is same as A14. Here coefficient of x1 x4 divided by 2. Here A41 A42. A42 is same as A24. Here A42 is same as A24. Here I am writing this same. Here coefficient of x2 x4 divided by 2. Here this is A43 position. A43 is same as A34. This is coefficient of here this is divided by 2. Coefficient of x3 x4 divided by 2. This is coefficient of x4 square. Coefficient of x4 square, and here this is simple x. So here which is equal to, here I will write coefficient of x1 square is A11. Here A11. So of course this is x transpose. Here coefficient of x1 x2 divided by 2. x1 x2 is 2 times A1 2 times A12, that is simple A12. Here x1 x3 coefficient of x1 x3 is here A13 2 times A13 divided by 2 is here A13, and A14 2 times A14 divided by 2, that is A14 here, and A12 here A12 is same as A21, right? A12 this is A22, so coefficient of x2 square. Here now A23 here right here this is A23 here. This is where 2 times A23 divided by 2, so this is A23. This is A24 2 times A24 divided by 2, this is A24. Now here this is A31 position. Here x1 coefficient of x1 x3. So here just write here A13 is same as A31, just write A13. So here this is A31 A32 position. A32 is same as A23, right here A23. So here this is A33. So this is here A34. Now here this is A41 position, but A41 is same as A14, right here A14. Here this is A42 position actually, but here A42 is same as A24, that is A24. Here this is A43 entry, but A43 is same as A34, that is right here A34, and this is A44, and this is x. Here this is the matrix notation corresponding to 4 variable. Here you can write again here for 3, that is x transpose here A. So here corresponding to this here x1 square, that is A11. Here A12 x1 x2 coefficient of x1 x2 divided by 2, that is A12 A13. So here A12 is same as, this is A21 position, but A21 is same as A12. Here I am writing A12. This is A22. This is A23. Here this is A31 position, but this is same as A13. A13. This is A32 position. This is A32, but A32 is same as A23. That's why here I am writing A23, and this is A33, and this is x. So here this is the matrix notation corresponding to the, this is the matrix notation for quadratic form of 3 variable corresponding to this. This is the matrix notation for the quadratic form for 4 unknown, which is corresponding to this. So here in this way you can write the matrix notation for the quadratic form. Now so here I think all of you know how to write the quadratic form in 2 variable, in quadratic form in 3 variable, and quadratic form in 4 variable. Thank you.